Good day, everybody. My name is Amit Khanna, and I'm an architect. We run an architecture practice called AKDA. When we're talking about, whenever I'm asked to give these sort of online presentations, I inevitably end up talking about sustainability. This is something that I think is core to what young architects should be thinking about, and it's also, it's something that has to become intrinsic to the process of every architectural firm, whether they like it or not. However, when I speak to my team and they always say you go on and on and on about sustainability, why don't you talk about something else today? So today I'll talk about our process and how our design is informed by our process and how our buildings emerge from what we think about the project. A lot of us have this notion as young architects that an architect's role is to sort of preach to the crowd as to what is the right solution. The fact is that when we are presented with a problem, we often don't know the correct solution to it unless we've spent some time with it. And this idea that the architect has a preconceived idea of how he's going to address this issue because it came to him at night in a dream, or he was walking and he picked up a leaf, and I think that's a bit convoluted and it's a bit um, unnecessary in this day and age. Architects fit into the ecosystem of how a building is made. There are multiple people involved, and we are one of the people who are making the project happen. And so our role is one of collaboration rather than of sitting on top of the pyramid and dictating the terms of what other people do. Every vendor brings in their expertise when it comes to making a building. And I think today, if you're talking about facades, then I would like to talk about the importance of having the right partners in while you're making a building. Today's sort of talk or whatever presentation centers around these two aspects of envelope design, and one is pattern and the other is perforation. Today we're going to look at pattern. Right? This is a project that we were assigned about 3-4 years ago. It was a large site where we were asked to build 100,000 square feet of manufacturing space for garments. This is in an industrial area of Delhi, and it's along the railway line. And between the plot and the railway line, there was a whole stretch of informal development. This informal development was one of the key things that we saw as the context of the project. So even though the buildings themselves are very large, about 50,000 square feet each, it was the contextual fabric that informed us as to how we should proceed on this project. And so when we were looking at how to detail out the facade and try and arrive at the appropriate material, the appropriate kind of colors, the shading, etc. We looked at the Google map of the site. We found that the covers of the roofs of these informal development had a pattern to it. So we picked up that pattern and we saw, okay, so how can we develop this pattern into a grid? Glass is available in certain standard sizes, and we didn't want to specify a grid that wasted glass just because it was an inch over or 2 inches over than the standard module. So we came up with 3 or 4 patterns that repeated. Those patterns were then subdivided into, again, subdivisions of the size of glass that is normal. We chose a few colors so that we get the correct balance of heat transmission. So in general, the darker the glass, the lesser heat is transmitted through it, the clearer the glass, the more heat comes through. But you have to strike a balance because you also want to ensure daylight, and you also want to ensure that people working inside can look outside and have a nice environment in which to work. So we took this pattern and we overlaid it onto the structural system of the facade. This is the product that emerged from this process. As you can see, it's divided into 2 parts. The lower end is plain glass, but it's got a slight overhang to it. but it's entirely uh, laminated frosted glass, right? Because there uh, we weren't looking for daylight. We weren't looking for, because the interior was a showroom. On the upper floors where we were placing the manufacturing, we were looking at daylighting. And you can see that there are different surfaces to the glass. So the facade becomes a self-shading mechanism in some ways. This is a detail of how the facade was put together. There was an aluminium framework, and some glazing is placed on the outside of it, and some of it is recessed inside. This is what it looks like from inside. As you can see, it is, I mean, slight digression here, but it's a large span structure. There are no columns in the middle of the buildings. It's about 15 meters width along the whole length, and the columns are only on the periphery. And what we've done here is that we've used a webbed sort of a ribbed slab approach, where we have a truss arrangement in the concrete. And so each of these beams is only 18 inches, despite the span being so large. Coming back to the elevation, you see how the members align to the grid of the columns, and how some of those colors, which seem very distinct on the outside, sort of sort of fade away when it comes to the daylight, because at the end of the day, the amount of light coming in a summer's day on, in a place like Delhi is far more than what a normal double glazing can show up as a distinctive color. The second project that I want to talk about today is a project that we were asked to do, a commercial building in Udyog Vihar, which is in Gurgaon. The interesting thing about this project was that we had it was, so the road that leads south out of Delhi is a large highway that sort of intersects the fabric of the existing landscape. And a lot of it is intersected at an angle. And this particular area, if you see, the highway on the right comes in at an angle, and if you consider the site to be perpendicular. And we thought that was an interesting starting point. So when we took the programmatic requirements of the site, and we looked at how one needs to place various service cores, we quickly came to an arrangement of how the system has to be planned. There were 3 service cores which were aligned on the non-critical sort of side of the envelope. These service cores had the staircases and the washrooms. Within this area, we planned for the most efficient structural system, only 4 internal columns, and then we raised it. And then came to the question of how to enclose this envelope. Now, this particular envelope was facing a less than favorable direction, unlike the previous project where we had a north-facing facade. This one was south, and so the essence was that we wanted to create some sort of shading mechanism. We took the idea of taking a glass facade at the rear, double glazed, and having it in a single color, and then creating this ribboned aluminium textured facade on the outside, which would curve, in 2 directions. This is the final result of the building. The aluminium glazing turns around the building, and it provides a really deep shading for the glass inside it. The angles that we had picked up from the site plan were used while articulating the joints of the aluminium. So all the joints where one aluminium panel meets the other is sort of angled, and this angle speaks to the fabric in that sense. The ribbons vary in height. The top ribbon is the largest, then it becomes smaller and then smaller as the building, as the shading requirement changes. It also tapers inwards. So what you can see here is that the topmost is furthest out, and the lowest floor is slightly smaller. This is a detail of the facade. As you can see how the aluminium, although it's laid out in strips, the the black lines are highlighted by this angular arrangement. This is another detail to show you the extent of the overhang that was employed just to achieve, the correct energy efficiency in the building. Again, these black lines being used to sort of articulate the pattern. This happens to be the headquarters for a sanitary ware company, and they had extreme requirements for daylight. So as you can see from the inside, it's quite bright, but you don't have to have sort of a singular glass facade in order to be able to achieve those daylighting levels on the inside. Although the building is curved, I should add, there are no curved glasses in the building. All of the glasses are straight. The third project I want to talk about is something that we were asked to do in a place called the Hosiery complex in Noida. This is an industrial suburb of Delhi, and it's a sort of a hub for garments manufacturing. The idea was that they wanted to create a state-of-the-art facility which would help them secure orders with buyers that were conscientious about sustainability. As sustainability becomes a mainstream issue because of climate change, every person who is employing another person to do something wants them to be sustainable while doing it. So it's not a question of, for instance, buying something at the cheapest cost. They also want you to take care of the environment in which your workers are working. They also want you to make sure that your building is of a certain quality, so that you're not spending too much on air conditioning, you're not spending too much on, utilities, etc. Fairly straightforward requirement. The ground floor had administrative and reception areas. We had, and there was a large section for packaging, finishing, and dispatch. On the first floor was where they had a showroom, managerial cabins, and the offices for the owners. 2 floors of production, second and third floor, and a cafeteria and a sort of breakout area for the workers on the terrace. Pretty straightforward layout in terms of plan as well. Rectangular plot, maximum envelope, minimum open space, only setbacks left. Structure devised for efficiency. Again, distribution of cores, etc. Pretty straightforward stuff. Again, the section is also, I would like to say, cookie cutter, because there is no, when you're working in industrial buildings, you have to optimize the manufacturing process, rather than keep one eye on how well you're doing as an architect in terms of section. This is the site context. We had neighboring factories that had all sorts of profiles, and we had a built mass that was going to go up slightly more than the scale of the surrounding areas. And we looked at the elevation, and we saw, okay, that we're going to have this arrangement where the daylighting requirement is more on the upper floors, and it's not much on the lower floors, pretty much for the first project, because that tends to be how factories get laid out. You do tend to have areas on the ground floor that don't need a lot of natural light. Quality control in garment factories means that you have to have artificial lighting, and you can't rely on natural light to examine colors, etc. So yeah, we had a greater requirement for light on the upper floors, a lesser requirement for light on the lower floors. And that gave us the idea that of creating, let's talk about making a graded building. And when we looked at a graded building, we thought, okay, what is the best way to do it? So we looked at 2 materials, again, aluminium and glass. A lot of these products are available in the standard size, which is 8 feet by 4 feet, 2400 mm by 1200 mm. If you divide it into 2 and then further divide it into 2, you get these 4 triangles. And these triangles, when turned on the side, can give you an arrangement of structure that is not only latticed for wind bracing, but it also gives you the efficiency that you want. So none of these panels waste material, right? And a latticed grid, like we saw in the first project in the roof, always gives you more structural resistance than a a plain Jane horizontal and vertical facade. So we looked at the idea of creating this pattern and having a triangular system of framework. Since we had the option of mixing glass and aluminium, we took 4 colors of aluminium, started with a darker color on the lower end, made it a lighter color as we went up to the building, and by the time it reaches the top of the building, the glass color and the aluminium color are almost similar. And that gives us a sense of how the building is sort of disappearing into the sky. This was the final elevation that was drawn out, where you can see all the sort of grayed out areas are glass panels. There's a density of dark blue, and that sort of blue dissipates as it goes up. Why we chose blue? Well, our company font is in blue, and I like blue, so it was blue. This is the building. As you can see, the sun sets against it, so you can see how the white panels on the roof, they sort of dissipate with the gray of the glass. This is a low E glass, again double glazed, and it has this sort of distinctive gray tint to it. This is the building and the surrounding landscape. Again, as you can see, the scale is slightly more than what it was, and we wanted to create an identity for the building. The aluminium fins had to be wind braced on the upper floor, and that gave us the opportunity that, okay, can we make it look like, the threads on the end of a fabric or the tassels at the end of a carpet? And so the idea being that, let us extend this framework above the building and leave them naked for them to be seen against the sky. This is what it looks like when the sun sets against it. Again, because it's got a lot of colors, it tends to produce this, this very varied appearance throughout the day, which is interesting, at least for architects. On the inside, very sanitized white environment for production processes. This is one of the quality control floors, white lighting, white surfaces. This is one of the production floors, again, optimizing services rather than trying to look at, unnecessary aesthetic choices. So a lot of, standardization based on equipment, based on how materials move, etc. So I want to talk about this, what we spoke about right at the beginning of the talk. When we are looking at a project, how are we measuring the success of how well we did when we conceptualized the response to the problem, how we articulated our design philosophy, how we got the thing built. And we find that we don't really need to focus on the stuff that, we're what popular media asks us to focus on. So we're not really concerned about whether it is cool or not. I mean, in terms of energy efficiency, yes, but not otherwise. We're not really concerned what other architects think about it, because they aren't our end customer in this case, and we're not really concerned with how it responds to the journalistic landscape of how architecture is written about. What we are interested in is, okay, is it efficient? Has it done the job well? Has it been less wasteful than ordinary Indian construction? Because Indian construction is extremely wasteful. We tend to not design in the modules that materials are made in. We tend to design and then we use the bits that we need and then throw away the rest. A lot of our tendency to measure our success comes from how well we have been able to look at the essential problem of the site. And have we engaged with architectural thinking? I mean, have we been able to develop the product to a sense where it speaks to a larger conversation rather than the one that we're having on a month to month or a minute to minute basis on Instagram? Are we looking at a larger conversation where, the architectural history of the world being 5,000 years, are we carrying that conversation forward, or is it just a pretty image? And so, I mean, I started with this that, we won't talk about sustainability because I want to talk about process. But as you can see here, at AKDA, our design process is all about sustainability. So there's no escape. Thank you very much.
Thank you. Thank you for taking us through a very insightful presentation, sir. It was interesting to see the simplicity of the final patterns, but the amount of creative thought that goes behind that. Before we close, I have a few questions that I'd like to ask.
Yes.
So do you use any tools or software plugins to arrive at an optimum form and a pattern for the facade itself? What research usually goes into dealing with facade design? We've heard about design builder and stuff like that, that people simulate the energy with and then go about their process.
Right. So I can tell you that we rely on two fundamental, you can call them tools, you can call them processes. We look at how the context is providing a environment of the solar path. So when we are modeling the building, we also model the context, which includes surrounding buildings, boundary walls, trees, and we look at it and not only in peak summer, but we also look at it, how it behaves in winter. The other thing that we tend to do is that we speak a lot to the manufacturers, right? And because they tend to have a more specialized approach as to how they're going to give us the right solution for something. So if we are perhaps designing a multi-story building and we're looking at a glass facade that has to cover both the visible section and the structural section, and the spandrel has to be covering a beam, but the main section has to, allow visibility. We don't want the surface to change on outside, but we want to use 6mm glass on the spandrel and let's say 18mm glass on the visible part of the facade. That means that we rely on the manufacturer to come up with the correct detailing to allow us to do that. And I think it's unnecessary for an architect to not only think that they have the expertise to be able to, solve all the problems, but it's also irrational. You have somebody spending, all their waking time trying to figure out what is the best way to put two glasses together. And it's best to listen to them rather than to come with your own thoughts about how it needs to be done.
Right. So facade design and their impact on regulation of the indoor air quality itself is a crucial point to consider while designing. So would you like to tell us about innovations that you do in this area, both active and passive, so that the HVAC of the building itself is optimized?
So when it comes to large scale commercial buildings, I won't talk about residential sector here because the residential sector is, it's not only is it extremely unregulated, but it's extremely customer specific. If you talk about commercial buildings, there are two main costs to the person who owns the building. There is the OPEX and the CAPEX. The CAPEX being what you spend up front, and the operating expenses what you spend over the life cycle of the building. Traditionally, if you consider that a building has a certain lifespan, the capital expenditure is only about 20% of the total cost of the building. So if you look at the total cost of ownership for a owner for a medium-sized commercial building, which is let's say 50,000 square feet, he has to keep an eye on how that building is going to perform over the next 50 years. Like you said, air conditioning is one of the largest guzzlers of electricity when it comes to a climate like ours. So you have two principal expenditures on a building. You have electricals and utilities, and you have maintenance. If you design a building that gets too hot, it needs too much air conditioning. If it needs too much air conditioning, you'll pay a lot in electricity. If you pay a lot in electricity, your operating expenses go up. Perhaps that was not such a well understood idea, let's say about 25 years ago. But as the typology becomes more common in a context like India, owners which have had the benefit of having built something that was, structure plus 6 mm toughened glass, have realized that just putting 6 mm toughened glass on the facade of a building may work in terms of aesthetics, may work in terms of, capital expenditure, but the operating costs are so high that it's unsustainable. So there is a growing sense of, there's a growing understanding that, okay, you know what, this isn't, Finland, and we don't want heat gain. We want to use glass on the facade because it's the simplest and quickest way of closing the envelope. But okay, let's spend a little bit more on the, on not only the on the glass, but also the thinking of how the facade is put together, whether it's thermally broken, whether it's a unitized system, semi-unitized system, and use that to temper the electrical requirements you have. Now you can brick it up. You can put ACC block all around it, but that increases your artificial lighting costs, and that's not really a nice environment to work in. The fact is that we have to have some glass on the facade because we have to fulfill daylighting requirements. We also want people to have a nice environment. The understanding that a better performance glass reduces air conditioning costs is now mainstream. And I think that, again, it's one of those things where, if you asked a facade consultant to have a meeting with a glass vendor and an air conditioning consultant, they would obviously come to the right conclusion, right? It's only when you bring in this idea of minimizing cost to the table, that's when you get into all sorts of trouble.
So speaking about energy efficiency, we see that the most common active strategy that is used around here is to incorporate solar panels on the roof. But is there a project where you have tried, incorporating BIPV into the facade design itself? And why do you think it's not so common in the country while we see it being used extensively abroad?
So BIPV, I think, is one of those technologies that is going to be absolutely normal, in another few decades, but it's just not there yet. We did a project in Delhi where we had to clad about 5,000 square meters of glass on the building. We considered BIPV. There are a couple of things, which don't work in its favor. One is if you're working with a vertical building and you clad it vertically, you don't really get the optimum utilization. You have to sort of angle it so that it's perpendicular to the rays of the sun. The other thing is that, buildings have 4 or more sides, and in essence, in again talking about North India, your prime sunlight gathering sort of side is east, south, and west. The angle varies on the east and the south and the west. It's lower on the east and west, it's higher in the south. So you have to sort of have a real commitment in terms of design philosophy for achieving BIPV. I think BIPV as a afterthought on the cladding of the building doesn't really work, which is where we struggled, in the sense that we had already thought of the building and we then said, okay, let's do a BIP facade. And I don't think that's the way to do it, which is why we couldn't. I think the way to do it is, okay, you know, to approach the problem and say, okay, this building, we're going to do BIPV on the facade. And what is the resultant form? There's this building in the UK, I think, which has, you know, solar panels all over it. They call it the battery box. And I mean, it does visually look very dark, and because of the size of the solar collectors, it also cuts a lot of light inside. I think it is going to be a combination of clear glass and BIPV, BIPV being on the spandrels and angled out, possibly to act as shading devices for the other glass. How you're going to clean that, how you're going to maintain that is, of course, a different matter. But having tried unsuccessfully to do it, I can tell you that the process to do it would be to approach it right from the outset that, okay, this is how we're going to build the building because it has to have BIPV. And I think going forward, like I said, maybe a few decades down the line, it will be absolutely normal. I mean, it'll be as normal as, as electric cars are today. It will be something that everybody is going to gravitate to.
Right. So is retrofitting of facades a good idea to help improve the energy efficiency of an existing building? Have you done that with any of your projects?
I mean, I think here's the situation. The sixth IPCC report came out a few weeks ago. I don't know how many of you had a chance to see it. Climate change is real. It's caused by humans, and it's going to, create havoc over the next 2 decades. You can either put your head in the sand as an architect and say, you know what, I don't care. I'm going to do my thing because, I like to design the way I like to design, and that's rubbish in my opinion. You have to think about how efficiently your buildings run. If your building is, an older building and you want to improve the efficiency of the building, should you tear it down and build a new one? Probably not. Unless it's really falling apart, you can fix most buildings. What do you need to do? You need to fix if it's too hot, you need to fix how it's how to prevent the heat from coming in. If it's too cold, again you have to sort of control the heat inside. A lot of it is to do with insulation. The insulation of the envelope is basically 3 key criteria. How do you insulate it from the roof? How do you thermally insulate wall surfaces? And what do you do with openings? Opening retrofit is reasonably easy, which means you take out a window which is, let's say, metal, those, MS frame, like I think we used to have it SPA about 20 years ago, which has 4 glass in it, which is literally like not having anything there, right? And you replace it with a aluminium, thermally broken, double glazed, properly insulated window. I think that's your first step. The second thing is to address the roof. The roof brings in 80% of the heat to the top floor. So just a silver coating or something that will reduce the heat gain. And if you can, then insulate the walls. But this idea that you need to produce an energy efficient building or you have to improve the energy efficiency of an existing building, it, to my mind, isn't even a question. I mean, if you look at all the conversation we have about cars and electric cars, it's a microscopic amount compared to how much buildings consume as energy. 30% of all electrical consumption worldwide is for buildings. And if you can improve that by 5%, that's a huge gain compared to, trying to convert, a few 100 million cars from fossil fuel to electric.
Is there a project where you have been able to measure or identify the impact of a certain method of facade design? For example, there are people compare the solar daylight analysis and annular sunlight exposure and other things through their analysis. Is there something that you've done to compare the energy consumption because of the design intervention that you brought in, the comfort or even the other factors?
Can this be a slightly longish answer?
Yes, for sure.
Okay, so I'm just going to take you through. Yeah, I'm going to show you this project. This is a industrial warehouse project that we did about 10 years ago, and it was greenfield site south of Delhi, about 7 acres of land, about 150,000 square feet of built up area. The brief to us was that we needed to create a warehouse where electrical items would be stored. Ideally, they should have been air conditioned, but because it was a large volume of space, we were asked to come up with an idea as to how we can reduce the internal temperature without having to resort to air conditioning and only use air cooling. We looked at the the way the building was going to be oriented, and we decided that okay, we had three requirements. We had to do an office block, a cargo bay, and the main warehouse, and we oriented the office block towards the north so that we could give curtain glazing on it and get maximum daylight. The warehouse was oriented on the south and the west, which is this block on the bottom left. This is the overall context of the site. So there was it sloped down towards the road, so we had to be mindful of how the drainage pattern worked in the building. This is the result. This is the solution we came up with. So this is essentially a double-skinned facade. We have a warehouse space inside, which is 20 feet high. There is a glazed surface, 1200 mm inside of the actual facade. That 1200 mm buffer acts as a thermal buffer for moderating both the light, the glare, the air temperature, and also allowing for access to the services. So this is also where we placed an array of coolers. On the outside of this, we clad it with a brick screen, and on the roof, we created a 200 mm layer of insulation. And again, this was covered with reflective white tiles. This is the resultant exterior of the building. On the right-hand side is the south facade, where you see this large screen. On the left, there is a very thin screen on the west wall. This is a detail of the brick facade. This is the interior. So because this was for an industrial client and they wanted to see how well the building had performed, they actually did an assessment of interior temperature versus exterior temperature over a 2-year period. The inside temperatures were approximately 12 to 15 degrees lower than the outside temperatures for 3 consecutive years during peak summer months. For us, that's a great gain, right? So what we've basically been able to do without air conditioning, we've been able to bring down ambient temperature by a third, from 45 to, let's say, 30 degrees or 32 degrees. We didn't have to rely on a electrical energy consuming device to arrive at this, something which worked 24 hours a day. This is a passive approach to energy efficiency, where we've been able to achieve the difference simply by knowing ahead of time what we had to achieve, right? A challenge is that some parameters are not normally laid out ahead of time. And so I think in this case, as architects, we need to be good listeners. If a client says, this is something that is important to me, you can use this as the basis with which you proceed with the design, right? And that delivers good outcomes for all parties. Yeah, I just wanted to share this with you.
Thank you so much for sharing your thoughts with us on the topic. And on behalf of Class Academy and as it ethos, we're very glad that you chose to do this with us.
Yeah, thank you for having me.
Thank you.